Hello students, today we will be discussing the concept of work done, which is very important concept in the thermodynamics chapter, because based on this work done we can apply the first law of thermodynamics also, which is another important concept. In first law there is a terminology work. How to calculate that work in various processes we are going to see today. See, in physics, you know how to calculate work, force into displacement. In the same way here, we will calculate the work done by using the pressure and the change in volume of the system. See, if P external, ext means external. If P external is constant throughout the process, then work done is minus P external into delta V of the system. Meaning, suppose if I have a piston like this, suppose there is a gas here and there is a external pressure here. If external pressure is constant, means what? Suppose if piston is compressed to this stage, let us say P external is 4 atm. Throughout the process, external pressure is stayed at a value of 4 atm and the piston is moved down. So, gas pressure is changing. When gas is getting compressed, its pressure will increase, but external pressure, if you see, it remained at the same value of 4. So, when the piston is in motion or when process is happening, external pressure constant. Such processes are called irreversible process. In such cases, work done formula is minus P external into delta V. For example, here if we apply, what is the external pressure? 4. So, minus 4 into final volume minus initial volume, that is what delta V. So, in this way we will calculate the work done in the irreversible process where external pressure is constant. Next, suppose if external pressure is not constant throughout the process, it is continuously varying from initial volume to final volume, which is called reversible process. In such case, how to calculate work done? Let us see. If P external is not constant and varying with time, that means suppose if I have a piston, it is compressed, but external pressure is continuously changing, not constant, it is continuously changing. Then how to calculate the work done on the system? WE means work done by the external forces on the system. That is minus integral of P external into dV. P external is not constant throughout the piston motion, so we cannot take P outside the integral. If it is constant, we can take outside. It is not constant, therefore it lies inside the integral only. We have to integrate it from volume V1, initial volume, to the final volume V2. Now see, suppose if P external is constant, then what happens? We can take this P outside the integral. Then if it comes outside the integral, then it will transform into minus P integral dV, V1 to V2. Now integral of dx value is what? X. Same way integral of dV value is V and limits are V1 to V2. Then it will become V2 minus V1. Minus PE into V2 minus V1 is nothing but see, you will get the same case with the previous one, that is minus P external into V2 minus V1. So, if P external is constant, this whole term will automatically transform into the previous one. If it is not constant, it cannot be taken outside the P external term. it lies inside the integral, we have to solve it. Okay. Now, so if you are dealing with irreversible processes, this formula we will be using. If we are dealing with reversible processes, then with this formula we will be using. Now, mainly in the examination, two processes which we often see in the competitive exams like NEET. One is isothermal reversible, isothermal irreversible. Let's see in these two cases how to calculate the work done. Now, first isothermal irreversible. As I already mentioned previously, irreversible means what? External pressure is constant. PE is constant. If PE is constant, then how to calculate work done? We know minus P external into delta V is the formula. So, in irreversible process, P external is constant. Therefore, work done formula we will be using minus P external into delta V. Suppose if they give question on the reversible process, then how to calculate? See, reversible process, here P external is not constant. See, P external is not constant. Therefore, you cannot write work done as minus P external delta V. That's why it is not equal. Then how to calculate? We use the integral. So, what is that integral expression? Work done is equal minus P external into dV. Now, P external is not constant, we cannot take outside the integral, but how to solve this? See, in reversible process, all the time external pressure and internal gas pressure are the same throughout the process, throughout the motion of piston. The external pressure and internal pressure of the gas both will be almost same, equal. Therefore, we can replace this P external with the P internal, P external with the P internal. So, P internal means what? Inside the cylinder what is there? Gas is there. So, P internal means gas pressure. So, I am replacing P external with the gas pressure here. Now, for gases we know PV is equal to nRT. So, in place of this pressure, since PV is equal to nRT, I can write P of gas as nRT by volume. So, I am replacing this pressure of gas with nRT by volume. Then, what are the limits of volume? V1 initial volume to the final volume V2. These are the integral limits. Now, since we are dealing with isothermal process, isothermal means what? Which is constant? Temperature is constant. And moles of gas anyway constant, because there is a gas inside the cylinder, gas is not leaking out or changing the moles. So, inside cylinder whatever amount of gas we have taken, that is same throughout the process, there is no change in that. So, moles is constant and isothermal we are dealing, so temperature is also constant. So, you can take this N, R, T, these three things you can take outside the integral because they are constant. Then what is remains? Minus nRT integral, and inside the integral what will remain? 1 by V dV. And 1 by V, 1 by x dx integration is ln x. So, 1 by V dV also integral is ln V. So, ln V and limits are V1 to V2. So, this can be written as minus nRT and substitute the higher limit minus lower limit. That means V2 when we substitute ln V2 minus when we substitute the V1 ln V1. Now, in logarithms there is a rule log A minus log B can be written as log A by B. So, ln V2 minus ln V1 can be written as what? ln V2 by V1. So that's what this ln V2 by V1. Now generally in our problems we will be dealing with logarithms base 10. Here ln means log base e. So we will convert this log base e to log base 10, which we generally deal in problems. Therefore, then it will transform into, see, when we put log base 10 here instead of log base e, then one multiplying factor will come into picture, that is 2.303. So here there is no 2.303, but logarithm is here log base e. When log base 10 is there, 2.303 will be there. Now here if you see, in case of isothermal process, P1 V1 is equal to P2 V2, because when temperature is constant, see, when temperature is constant, PV will be constant. When PV is constant, you can write P1 V1 is equal to P2 V2. Then V2 by V1 can be replaced, if you want it can be replaced with what term? V2 by V1 is P1 by P2. So that's why here you see P1 by P2 also. Depending upon what is given in the question, if initial volume and final volume is given, we will use log V2 by V1. If initial pressure and final pressure is given, we will use log P1 by P2. And don't forget the negative sign here. And sometimes in options minus 30 joules will be there, plus 30 joules also will be there. So sign is also equally important here, not just the magnitude. And one more thing you remember, this work done, whatever we are calculating here, in irreversible process we use minus P external delta V, in reversible logarithm formula we use. In both cases, whatever work we are calculating here, it is actually work done by the external forces on the system. If this is the system, what is the work done by the external forces on the system, we will get here. Next, one more point you keep in mind, when piston's mass is negligible, usually whenever we are dealing in problems, we consider piston's mass as negligible only. When piston's mass is negligible, net work done on the piston is 0. Because in physics you have studied, net work done on any object is equal to total change in energy. And so here object is what? Piston. Net work done means work done on the system, on the piston by the external forces, and work done on the piston by the gas. Both together you take net work done. So net work done is equal to total change in energy of the piston. And what is the energies we consider? Potential energy mgh and half mv square kinetic energy. But since mass is negligible, the potential energy mgh as well as kinetic energy half mv square, both will become 0 here. So the change in total change in energy will be 0 for the piston. So when total energy change is 0, total work done, which is equal to total energy change, that is 0. Work done by external forces and work done by the gas, these both on the piston will be 0. Now you see clearly, work done by gas is equal to minus of work done by external forces. So sometimes they will ask, what is the work done by the gas? What is the work done on the gas or on the system? When they ask work done on the system, WE we are going to calculate, means external forces doing work. If they ask work done by the gas, then just first calculate the work done on the gas, WE, and we will change the sign. That is how we calculate. Next case, work done in free expansion. See, work done in free expansion means what? A gas is expanding but freely. Freely means there is no opposition to the expansion. No one is opposing the gas from other side when it is expanding. For example, see, there is a gas one side, other side vacuum is there. we have opened the slit so that gas can move into the other chamber. See, here gas is rushing into the other chamber, and what is there in the other chamber? Vacuum. No one is there to oppose this gas. So, without any opposition on the other side, gas is expanding, increasing its volume. This is called free expansion. So, in such case, since no one is there to oppose, external pressure will be 0. While gas expands, there is no opposition. That is, external pressure is 0. When external pressure is 0, then we know in work done minus P external to delta V. If no external pressure is there, P external is 0, then work done automatically becomes 0. Therefore, remember in free expansion, work value is 0. Whether work done by the external forces or work done by the gas, both will be 0 because they both just differ in the sign only. If W is 0, work done by the gas also 0. Next, let's see few problems to get idea how to apply this in the numericals. Now, an ideal gas is expanded isothermally. See, whenever you solve the problems, first circle or underline the important words which determine the path of the solution. So, now here isothermal is very important word, isothermal. And from what state to what state? 10 decimeter cube volume to 20 decimeter cube. And remember, 1 decimeter cube and liter both mean the same. So, whenever you come across decimeter cube, replace it with the word liter. Read it as liter. Same only. Against 4 atm pressure. Against 4 atm pressure means what? Gas is expanding, increasing its volume from 10 to 20. Against means outside what pressure is there? Outside 4 atm pressure is there. Against that pressure it is expanding. That is the meaning. So, they don't mention the words clearly that external pressure is so and so like that. We have to understand from the statements. So, here against 4 atm pressure means this is what the external pressure. That is the meaning. Now, find work done. When they say simply find work done without specifying whether work done on the gas they expect or work done by the gas they expect, just remember when they just say work done, by default we have to calculate work done by external forces on the system. That means WE we need to calculate. So, here we know WE, there are two formulas. One is minus P external delta V in isothermal irreversible. Second formula is logarithm formula. Which formula we need to apply here? Remember, whenever we are dealing with irreversible process, minus P external delta V we have to use. Whenever we are dealing with reversible process, isothermal of course, then logarithm formula, log V2 by V1 formula we derived, that formula we have to use. Here, how to know which process it is? Because they have mentioned isothermal, but they have not mentioned is it reversible process or irreversible process. How to identify that so that we use the right formula? Remember, whenever you see the external pressure constant external pressure, understand that it is a irreversible process. There is another way to identify. See, in case of reversible process, they will definitely mention the word reversible at some place in the question. So, while you read the question, you will see the word reversible. If you see that, understand it is reversible process. If you don't see the word anywhere in the entire question, read carefully. If you don't see the word reversible anywhere, understand it is a irreversible process. It is one short way to identify which is reversible and irreversible. So, therefore, as you see here, there is no reversible word anywhere. So, it is irreversible. Therefore, work done is formula minus P external into delta V. V final minus V initial. Now what is external pressure? External pressure is 4 atm. Final volume is 20 decimeter cube, means 20 liters minus 10 liters. So 40 atm liters. Sometimes units atm liter can be there, sometimes units can be joules also. Then how to convert? If you want to convert into joules, remember 1 atm liter is equal to 101.3 joules. Therefore, in place of atm liter, we will put 101.3. You will get the joules. 40 into 101.3 will give you joules. So this is how you have to calculate work done. Whenever they say just simply work done, it means work done by external forces on the system. Next, final pressure of the gas. How to find final pressure? Means piston is going outward, gas is expanding. Some place it will come to stop, piston. When it stops, what is the pressure of the gas? That is the final pressure. Now imagine that when a gas is expanding, piston is going outward, when external pressure, internal pressure of the gas, when this both equalizes, then the piston will come to stop. So final pressure of the gas will be equal to the external pressure, then only piston will be stopped. And we know external pressure 4 atm. Therefore final pressure also 4 atm, because when external pressure is 4, internal pressure also 4, then only piston will be stopped. That is the final stage. So final pressure of gas also will be 4. Let's see one more problem. Same, an ideal gas 2 atm and 2 liters compressed isothermally. Again, this is an important word, isothermal, against external pressure. See, this is what they have given here, specifically external pressure. Sometimes they don't give, just they say against the pressure of. That is also external, meaning external pressure only, that means. So this is external pressure. I will write here P external 5 atm. And what is the initial pressure? 2 atm is the initial pressure. Initial pressure of the gas is 2 atm. And initial volume 2 liters. Find, first part of the question is what? Final volume of gas. Okay. Now, how to get final volume of the gas? We know initial volume, we know initial pressure. And how to get final volume? See, since isothermal process, in isothermal PV is equal to nRT, if temperature is constant, isothermal case, then PV is equal to constant. If PV is equal to constant, can I write P1 V1 is equal to P2 V2? Now, P1 we know, given in the question only, V1 also we know, final pressure we don't know, and final volume we need to calculate. How to solve this then? Listen, in the previous problem we have discussed, when piston is going outward, finally it comes to stop. When it comes to stop, when internal pressure and external pressure matches, then only it will come to stop. The same manner, initial pressure is 2 atm. Final external pressure is 5. So piston is compressed and finally when internal pressure of the gas also becomes external value, that is 5 atm, it will stop. Yes or no? See, there is a piston. External pressure is how much? 5. Internal pressure is initially 2. So external pressure is more, so gas will compress, piston will come down, and finally external pressure is constant only. Internal pressure will increase when piston comes down, and when internal pressure also become 5 atm, then piston comes to stop. It stops, it does not move further. That is the final stage. And what is the pressure of the gas here? Same as external pressure, 5. So we know P1, that is 2, we know V1, that is 2, and P2 also now we know, final pressure 5 into V2. So therefore final volume is what? 4 by 5. 4 by 5 means 0.8. So 0.8 liters is the final volume. That is the first part of question. Next, work done on the gas. See, work done, second part of the question is work done on the gas. Means work done by the external forces on the gas. See, work done on the gas, how to find? There are two formulas, logarithm formula and without logarithm, minus P external into delta V. Which one we have to use here? I told you in the previous problem, if there is a reversible word, then we will use logarithm formula. Here anywhere you see reversible word, if you read the question carefully, you don't see anywhere reversible word. That means it is irreversible process. Work done is minus P external into delta V. P external is 5 atm. Final volume is, just now we got final volume 0.8 liters, and initial volume is how much given? 2 liters. Final volume is 0.8 liters, initial volume is 2 liters. That means minus 1.2 liters. Now just multiply 1.2 into 5 and you will get the work done by the external forces on the system. What about third part of question? Work done by the gas. We already know work done on the gas and work done by the gas. These two will be opposite in sign. So whatever answer you get here, just change the sign. You will get here positive 1. Now you put the negative sign before, you will get the third part of the question's answer. So like that. Next, see an ideal gas. Again, initial pressure is given. What is P1? 2 bar. What is V1? 10 liters. Again, isothermal. But see here, reversible word, reversible process. So work done formula will be having logarithm, remember. And to what state? Final volume 1 liter. So V1 with 10 liters, final volume is 1 liter. Find work done. Work done means work done by, nothing is mentioned here on the system, by the system. If nothing is mentioned, by default we calculate work done by the external forces on the system only. So is equal. We should not use here minus P external delta V. Remember, it is reversible. So what is the formula? Minus 2.303 nRT log V2 by V1. Now see, V1 we know, V2 we know, but if you read question, there is no information on moles and there is no information on temperature. So we don't know N value, we don't know temperature value. Then how to proceed? See, Since it is isothermal, we can write P1 V1 is equal P2 V2 and that is equal nRT. P1 V1, P2 V2 and nRT all same only in isothermal. So we know P1 and V1. So we can replace nRT with P1 V1. P1 into V1. What is P1? 2 bar. P1 is 10 liters. So 2 into 10 and logarithm final volume by initial volume. What is the final volume? Final volume is 1 liter. Initial volume is 10 liters. And this you can write minus 2.303 into 20 into log 10 power minus 1. 1 by 10 you can write 10 power minus 1 and log 10 power minus 1 you can bring that minus 1 to the front side and you can write minus 2.303 into 20 minus 1 if you bring front minus 1 into log 10. Log 10 value is 1. But they are asking in the question, if you see in joules they are asking, but when we take pressure in bar, volume in liters, we will get answer in bar liters, but we need to calculate that work done in joules. So how to convert this into joules? See, 1 bar liter is equal to 100 joules. This is the conversion. So therefore minus into minus is plus 2.303 into 20 and log 10 value is 1 and but unit is what here? Bar liter. So 1 bar liter is 100 joules. If you multiply, you will get the answer in joules. So this is how you have to calculate the work done. See, so if I have to summarize the whole discussion of today, see, two types of problems you will get. That is one isothermal reversible process, other one is isothermal irreversible process. In reversible, use the logarithm formula of work. Irreversible, use the non-logarithm formula is there na, minus P external delta V. Use that. That's it. So this is the main concept of work done. And if nothing is mentioned in the question which work they want us to calculate, by default calculate work done by the external forces on the gas or on the system. That's it. I hope this lecture is helpful to you. So practice some problems on this. Take some previous year's questions or Sri Chaitanya material module you take and practice some questions on this concept. You will get more clarity. When you get problems, first after understanding the concept you have to solve, practice. Because by practicing only you will get more confidence. When you are getting answers, you will get confidence. That will help you in scoring more marks in exams. Thank you.